Hello and welcome to another edition of Zog Science. Today we're going to be looking at valence electrons and Lewis structures. So what I've done here is I've taken the periodic table and I've sort of just taken a couple of sections of that. We're looking mostly at our A elements, and those because those have nice simple rules when it comes to energy shells and valence electrons, and subsequently it makes our Lewis structures very easy to write. So let's just sort of dive right in. So if you'll recall, these numbers up here represent the group numbers for our different columns of the periodic table. So the columns of the periodic table are called groups, and these numbers up here at the top represent those groups. Now you'll notice that we've got 1, 2, and then we skip to 13. It's because I've taken out the transition metals, which would normally be occupying this space, and instead we're just going to be focusing on the A group elements. So you see we've got 1A, 2A, 3A, 4A, 5A, so on and so forth. And the reason why I've done that is because the A elements, this number right here, corresponds with the number of valence electrons that they have. So if we take a look right here, we've got hydrogen. Okay, it is in group 1, so it has 1 valence electron. Beryllium and magnesium are both in group 2, so they have 2 valence electrons. Now, what is a valence electron? Well, let's take a look at carbon as an example. So I've got carbon, okay, and let's go ahead and draw some energy shells. Now this is in the second periods, or second periods. So that's 1, 2. So it's going to have two periods. Two energy shells. We can also show this by drawing out our Bohr model. So we've got 1 energy shell, okay, and if you'll recall, energy shells, the first energy shell can hold 2 electrons. So I've got 1, 2. Okay, and carbon has an atomic number of 6, which normally means that it has 6 electrons. So I've only got 2 right now, so I have to draw my second energy level. Right, so now I've got 2 energy levels. I'm going to put my 4 remaining electrons in this energy level. Right, so if you count them up now, I have a total of 1, 2, 3, 4, 5, 6 electrons, which corresponds to our atomic number, so we are all good there. Now in terms of valence electrons, our valence electrons are the electrons that are in the outermost energy level. So I'm just going to circle those real quick to highlight them. And you'll notice that we have 4 valence electrons, 4 electrons in the outermost energy level. Hey, check it out, 4A, group 4. Okay, so that's how we can tell that whatever group number it is, that's the number of valence electrons we have. Now, when it comes to writing Lewis structures, right, Lewis structures are just going to basically say, okay, we know that any level underneath that top energy level is going to be full. So all we really need to do is we just need to show the number of valence electrons. So again, we're just showing valence electrons. All we're going to do is we say, okay, we have 4 valence electrons because we're in group 4A. So I'm just going to put a dot here, dot here, dot here, and a dot here. So what we're showing is that we've got 4 valence electrons. Now the reason why we're spacing them out like this is because later on when we talk about bonding, it's very important whether or not these are paired up with one another or whether or not they are just sitting there all lonely like they are right now. So let's do one more example. Let's do oxygen. So there's my oxygen. And what group is it? That's right, it's group 6. So I've got 1, 2, 3, 4, 5, 6 valence electrons. All right, so we got 6 valence electrons here. You'll notice that these 2 are paired up and these 2 are unpaired. That basically is going to come down to the fact that oxygen can create 2 bonds when it is going to be creating new substances. All right, thanks for watching, and I'll see you next time.